Okay, Gerald, I think you missed the video. Basically, we've just shown the video that, highlights what does it mean by matter. And then it briefly talks about the three states of matter and also focusing on how matter has mass and occupies space. I think that is one of the criteria that determines whether something is a matter. Okay, basically any matter must have mass and must occupy space. By occupying space, basically we mean volume. Okay, it has volume, right? So examples of matter here on this page, some examples would be like, a pen, a car, a flower, a bird, even smoke, because smoke are made of like tiny particles, which are solid particles. Okay, and of course some gases as well. So smoke is actually a matter. Now, what are examples of non-matter? Usually, if you realize the examples of non-matter are generally those that are like um energy. Okay, like any forms of energy, like for example, sound energy, light energy, heat energy, all these are non-matter because they don't have mass and they don't occupy space. Okay, so remember for an object to be a matter, it must have mass, it must occupy space, right? Another common example would be shadow, because a shadow does not have mass, a shadow does not occupy space, right? So all these are examples of non-matter. Now, remember we said that matter must have mass. So what do we mean by mass? Mass is actually the measure. Okay, maybe you just want to zoom in here. Okay, mass is the measure of the amount of matter in an object. Now, you have to, I think it's stated in the video, mass is not the same as weight. When we say mass, it's basically the amount of matter in an object. If you go to outer space, like if you go and land on the moon, does your mass change? If you go on the moon, does your mass change? That means, does the amount of matter in your body change? Yes or no? No, right? I see Ivan shaking his head. If you go on the moon, if your mass change, it means that do you go on the moon and somehow one of your arms go missing or one of your legs go missing or your head go missing? No, right? Okay, so the mass does not change, but when you go on the moon, actually your weight changes. Why is it that your weight changes? Because weight is actually the amount of gravitational force thing on you. So when you go on the moon has lesser gravity than Earth, right? So the amount of gravitational force or the amount of gravity acting on you changes. So because of that, your weight on the moon changes, but your mass don't change because the mass is the amount of matter inside you. Okay, so of course, like I said, doesn't mean you go to the moon means some of your internal organs go missing. Okay, so that is mass versus weight. So how do we measure mass? Usually, we use apparatus such as electronic balance, a lever balance, or a spring balance. The one on the right is actually a spring balance. Okay, so all these actually can tell us the mass of an object. So all these apparatus are used to tell us about the mass of an object. Yeah. Okay, now next one. Matter occupies space. Now, what does it mean by space? Space basically means the amount of the volume basically means the amount of space occupied by an object. So how do we measure volume? Usually we will use either a syringe, especially so when we are measuring gases. A gas syringe can help us to measure volume of gas. We also use a measuring cylinder, right? And graduated cylinder, maybe I just want to show you how a graduated cylinder looks like. Hold on a second, yeah? Oh, it's the same actually. Yeah. Okay. So this is a graduated cylinder. Basically, it's like a measuring cylinder. And you usually use it in labs, right? Usually use it in science labs. Okay. And sometimes we use a displacement can. So a displacement can actually basically means that we will put something in and then it will displace out the water. Okay, let me see if I can show you a photo of a displacement can. Okay, so when we put something inside, this one is a very good diagram. Okay, so when we put things inside the displacement can, we actually have to fill the water to the brim here first, to the top of this, just before the spout. Okay, so when we put an object inside, the water will be displaced out into a measuring cylinder. So whatever the amount of water being displaced out is actually the volume of the object that is placed in the displacement can. Okay, so this is a displacement can. Okay, great. Now, let us now answer the questions. Okay, we will have a break in between. I think there are a total of, this time around there are less questions, but there are more open-ended. Okay, so we'll see. Right. Okay, there are a total of 10 questions. So we'll stop at question 5 for a short break, yeah? All right, Christy poured water into a beaker containing some stones. Some air bubbles were seen moving upwards as shown. After a while, the water level was lower than that at the start of the experiment. Okay, slightly lower. So which of the following explains why the final water level was lower than at the start of the experiment? Anybody? Yes, Grace.
B.
C for cat, is it?
B.
B for boy? Or D? D, is it? D for dog. Okay, yes. Okay, so you're right, because the air rises and the water actually took up the space that's occupied by the air between the stones. So the air escaped and then the water was able to go into the, to take up all the spaces left in the stones. So that caused the water level to decrease. Very good. Okay, the answer is D. Any questions for this? Someone type in the chat, is it? Let me have a look. Oh, nobody. Someone deleted it. Okay. Now we move on to question 2. Alexa poured some water into a measuring cylinder and recorded. Oh, Suen is coming in. Hold on. Okay, question 2. Let's see. Alexa. Okay, Alexa poured some water into the measuring cylinder and recorded its volume as X cm cube. She then put 3 identical marbles into the measuring cylinder and noted that the volume was now Y centimeters cubed. Next, she put 2 identical metal cubes into the measuring cylinder and recorded the new volume as Z centimeters cubed. Which of the following can she use to find out the volume of each marble and each cube? Now, this one is like mathematics, okay? So you have you have 3 marbles here. So to find the marbles, you probably have to take y minus x and divide by 3. Because when you take y minus x, you're finding the volume of the 3 marbles, right? The difference, and then you divide by 3. So the answer would be B, isn't it? Because that's the only one. Okay, but just in case you want to check, then you might just want to take, because this one has 3 marbles, this one has 3 marbles, but this one has 2 metal cubes. So you might just want to take Z minus away y, then you divide by 2 meter cube. Okay, so the answer is B. Right, this one is more like a mathematics question rather than a science question. But sometimes for the topic of matter, they might test you something like that. Okay, any questions? No? Okay, if there aren't, I'm going to move on. Okay, Alia took a sponge and dipped it in a container of water as shown. How can she find the mass of the water absorbed by the sponge? Okay, this one is more of like experimental kind of question. How do we find out the mass of water absorbed? So of course, you will have to you will have to take the mass of the wet sponge minus away the mass of the dry sponge. Okay, so for this one, the answer would be C. No, sorry, D. Okay, you take the mass of the wet sponge minus dry sponge because the difference is then the mass of the water. Okay, so you take the wet sponge minus the dry sponge, you get the mass of the water, which is in the sponge. All right, now, question 4. Bob had a gas syringe containing 20 milliliters of hydrogen gas. He transferred all the gas into a 15 milliliters test tube as shown below. Okay, so he was able to do that because, why was he able to do that? Anyone? Yes, Catherine.
Gases have no definite volume.
Very good. Okay, because gases have no definite volume, so therefore we are able to compress it. If it does not have definite volume, we can compress. And he was able to, put in 20 ml into a 15 ml, so you can compress it because of the property that it has no definite volume. Okay, we're going to do this open-ended question. Two similar syringes, R and S, contain substances X and Y respectively. The end of each syringe was sealed. The plunger of syringe R could not be pushed in while the plunger of syringe S could. What is the likely state of matter of substance Y? Yes, Ivan.
Gas.
Well done. Okay, so for this question, it's a 1-mark question. You just need to write. Maybe you want to just write gaseous state. Okay, because what is the likely state? So gaseous state. Yeah, good. Okay, gas is accepted as well. So you have to explain your answer. So obviously, because of when it comes to explanation question, try to use the claim, evidence, and reasoning. You've already stated your claim. Your claim is that it's a guess. Okay, so where is your evidence? Your evidence is that you can see that substance Y, right? What can you observe? Substance Y can be compressed. Okay, so substance Y can be compressed and only gases can be compressed, right? Then your reasoning, you link it back to your question. Therefore, substance Y is a gas. Okay? Okay, so that answers will then be complete. You have to make evidence. Yeah, Y can be compressed and only gas can be compressed. Therefore, it's a gas. Okay, now next one. Draw a line to show the water level in part B and C. Anybody wants to describe? How do you think you will see the line? Yes, Catherine.
It will be the same water level.
Very good. Okay, it will be the same. So please use a ruler. Excuse me. Where is the ruler? Okay. Okay, so you have to draw, make sure the lines are straight.